Yeah, I mean, this is the same as last time.
Another airfield, another weather station. Which one is it today?
Welcome to part 4 of the LDS road trip. LDS, of course, standing for the long drive of statistics, which this certainly is. Shout out to @R4Y7, who through the first few shorts that we made correctly surmised before the first part came out that we were indeed doing a trip of all of the LDS locations that we need to go to. And where do we find ourselves today? Well, we find ourselves in Leeming, a sleepy northern English village with really absolutely nothing in it of any interest except for a service station, which we've been to and was terrible, and an RAF base, which is behind us. And that is the entire thing that's going on in this town. We were quite conscious that this would make a very boring video because there is so little here. But if you pan over, we might have possibly one of the best shots of what we're really here for that we've got all week, which is a fantastic tower. This is the RAF base with our weather station just right in there, which is fantastic. So we will make all of our recordings basically only 100 meters away from location.
So after getting our readings from Camborne, we knew we had a really long journey back to Birmingham before going even further north to get to the last two destinations. So we did actually take a rest day in Birmingham before heading to Leeming, but eventually we took the journey from Birmingham, and as you can see, we arrived in Leeming ready to take those all-important measurements and to make sure we were in the right place to answer some questions from a large data set about Leeming itself.
So here we are set up at Leeming, just outside of RAF Leeming. We've got our table and we're here only a few meters away really from the weather station. As it's a weekend, we've not been allowed access to the actual airfield or in fact even the car park. So we're just outside, but we've got the table, we've got all of our equipment, so we can do some weather readings. Should we get started?
Let's get started.
Okay, breaking news, LDS tour fans. We have a new device, and it's in this bag here. We were able to get this on our rest day back in Birmingham, and here we go. Look at those fans moving.
Oh my word.
Already.
What is it, sir?
The exciting thing about this device is it will take pressure and humidity.
Oh my gosh, 2 in 1.
2 in 1.
2 in 1.
2 in 1. Pressure and humidity we have fairly ignored so far. So I'm quite excited to take these readings. Anyway, let's turn it on. Okay, we're on. So this still does the wind speed. So let's hold it up.
Oh, it does that as well?
Yeah, no, it does it all.
Oh my God.
And I'm putting the winds into knots, and here we go. So I'm just holding it up, and this has also got another feature that it will find the average wind speed in the time that we measure. I've got a wind speed now of 2.1 knots. 2.1 knots. And if I press this button here, it will calculate the average over the time I've held it up. And to be fair, this average probably isn't over a long enough time period, but we've got an average of 0.9 knots, and we've got a maximum of 2.5.
So that's our gusting of 2.5, average wind speed of, what did you say?
0.9 knots.
Awesome.
Brilliant, excellent. Now, we've got more to do on here.
Of course we are.
Next one, temperature. Now, we do need to say something about temperature because we've just been naively reading it off the chart.
So here's the extract from the large data set about daily mean temperature. Of course, interesting to note that this is meant to be the mean across the whole day over hourly readings, but for some very interesting little details as well. Did you know that they took the temperature at 1.25 meters above short grass?
The temperature here on this lovely summer's day, and we're in August now, aren't we? This lovely summer's day is 26.5 degrees Celsius.
Despite your coat.
Despite my coat. Well, those gusts can get to you.
Yep.
The extra readings, the ones we have thus far ignored. And that is pressure and humidity.
Tell me the pressure.
Right, barometer button is being pressed. Now it does feel quite settled out here, to be honest with you. So I'm expecting a slightly higher pressure, and we've got 1014 hectopascals.
That sounds good. That sounds pretty average.
Yeah, maybe slightly on the high side, maybe pretty average. We'll have to look it up later.
Since we actually measured pressure for the first time then, let's just talk about it a tiny bit. In the actual large data set, this here in the box is what they give you, just some information about how it used to be measured in bars and millibars, but now is in hectopascals. Not really very interesting. This here is what the Met Office talks about when it says about how it describes and measures atmospheric pressure. Some really interesting stuff in here. Firstly, any movement of air across a barometer like we would have had when we did our measurement will cause a drop in pressure, and so that maybe means our measurement might be a little bit out, and this is probably why you need some quite specialist equipment to do this properly. But also, even more interestingly down here, they actually scale their pressure measurement according to sea level. So if you look in the large data set, you'll see that Leeming is not at sea level. Of course, it's quite far inland, which means their pressure readings that they do in their weather station, they actually apply a special formula to whatever number they get, taking into account all these various things that we would have had no possible chance of measuring accurately. And then they get some new reading that estimates what the air pressure at sea level would have been if Leeming had been at sea level. So yeah, I thought that was quite interesting.
So, relative humidity then. We've had this out for a while now, and the numbers seem to be coming down quite a bit. And the humidity seems to be quite low today, 37.8%. And maybe we need a little bit of an explanation of what that actually means.
And in the large data set, that would be round just the nearest whole number, I would believe.
38%.
Here is the information again from the large data set about humidity. Now, importantly, what is recorded in the large data set is the daily maximum relative humidity. Now, this occurs normally shortly before sunrise, where you maybe expect the dew on the grass and things like that. And so even though our reading was quite low here in Leeming, this higher percentage happens earlier in the day. Again, just to reiterate this, this is the percentage of the air saturated with water vapor. So if it's a higher percentage, it's closer to being that the water is condensing out to give you this mist and fog, as it says there.
Time for rainfall. Now, I have been exceptionally disappointed with the British weather on our trip, because I mean, we've driven through a lot of rain, but every single time that we've stopped, the weather gods have said no rain. And we've been here, I would say actually on this occasion, for 10 minutes already. 10 minutes. So whatever is in here, we need to multiply by 6.
Yep.
And then by 24.
Yep.
But you know what's going to happen. No rain. There is a storm actually forecast for tomorrow, Storm Floris, which is apparently coming through over northern England and Scotland. So maybe we'll get some rain at the next destination. Sunshine hours we should talk about, because again we've not really talked about that very much, and it's incredibly difficult for us to measure it, of course, because we're only in these locations for a short amount of time. Again, it's sunny. Octas. What do you think,
everyone? There's a tree in the way there, and then there's a bar. Let's go this side. I mean, there is a bit of blue, but it is mostly cloud. This is the extract from the large data set. Cloud cover is measured in eighths, which is octaves, and it's the amount or fraction covered of the celestial dome. Easy. Now, this extract comes from the Met Office itself. There's a couple of really interesting things in here. You can give it a read if you like. But one thing down here, 9 octaves is possible. Really interesting stuff. That's when the sky is obscured by fog or other phenomena. The other thing that I thought was really interesting is that this is only measured, they only measure the cloud or the sky that passes directly above the instrument, not the entire celestial dome, unless a human observer is present to look at the entire celestial dome. To give you a demonstration, here's a picture of a sky, and like, what if we wanted to say how many octaves we think this is? Well, one super basic way I could do this is I could just take snippets of cloud that I can see, right? I'm going to say this is about 25% cloud. Of course, 25% of an eighth would be 2 octaves. So I think we'll describe this original picture, if I go all the way back, as 2 octaves, probably. Who knows? Maybe I got that completely wrong.
So there's been some conversation about where you could get your own flag like this. Presumably lots of people wanting to do their own weather recording with a flag like
The
this.
only reason you'd want that flag,
It's
surely.
limited edition, what can I say? Anyway, so let's hold up this flag.
Oh, we're seeing something here.
This way.
That way?
This way. That flag just got some unwanted attention, so we've cut. So now I have a compass in my hand. I remember it was that way.
Somewhere over there.
Okay, so that's the way that the wind is blowing. Set up my compass, align the north, there we go. And that is an angle of 115 degrees. So therefore it's coming from an angle of 290, and I think that would be a cardinal direction of west-northwest.
Amazing. We are in Leeming. The only thing left to do is to do the large data set question from Leeming. We'll bring up the question on the screen as always. Now, looking at this question, this looks pretty familiar. It's talking about some sample that he's taken from rainfall figures. These might even be, this is a different question to what we did a couple of days ago, but it might even be the same numbers. It's going to ask us to do a standard deviation, and then it's going to ask us why it's not suitable to do, yeah, I mean, this is the same as last time. On the screen will be the second question about Leeming. And now this looks like a box plot, so that's, you know, I love a good box plot. I've raved about them in past videos. So we're looking at this box plot here. This guy thinks it's about rainfall. He thinks it should be swapped around. Now, if we talked about this a couple of days ago, actually, rainfall measurements in the large data set, there's a ton of zeros and then there's some other numbers. So when you're drawing a box plot of it, think about what it looks like. The lower outlier and the lowest value, and maybe even the lower quartile, are all just going to be at 0 because there's so many zeros. So I think we can justify that this right-hand end, where the upper quartile meets, or just ends, that must be the 0. So therefore this thing needs flipping over. So the 0 is on the left, as it always should be, and then the higher values are on the right. Oh, and I've just noticed, this question actually started by talking about Hearn's total rainfall. Always read the question, it's very important. Hard to read if it's flipped over. So now we get to daily mean visibility in Leeming. Okay, so we get a lower quartile of 1,000, upper quartile X in DAMs, decameters, remember that? We have this standard definition of an outlier, 1.5 times the IQR above and below. Last 6 values of that, he believes that there are 5 outliers. Ooh, we get to do some proper algebra here. So I'm going to say that the IQR is X minus 1,000, because that's the upper quartile minus the lower quartile. Now, if I times that by 1.5, so I've got here down 1.5 brackets X times 1,000, I think I can then add that to the upper quartile, which is X. So it's going to be 1.5 brackets X minus 1,000 plus X. Now, if I want 5 outliers, I want that to be between 3,400 and 3,300, because that way it'll be bigger. It'll be big enough to exclude the 3,300, but not big enough to exclude the 3,400. So I think that's fantastic. I think I'll go with that. And now it looks like I just need to solve this for X. So if I expand that out, that makes 2.5X minus 1,500 is less than 3,400 and 3,300. Add 1,500 to both sides. Can I do this non-calc style? That's going to be 4,900 and 4,800. And I need to divide those two numbers by 2.5, which I absolutely can't be bothered to do without Mr. Winfield's calculator. So we will do this, and we will actually type it correctly. I'm not used to typing things in here. 1960, X is less than, and it's bigger than 920. The first 6 values are those, so now we've got some smaller values. Nish believes there are 5 outliers at the lower end this time. Okay, and works out that the possible list of X is 1267 to 1400. Given that there are only 5 outliers in total, explain why Nish is not correct. Well, of course, if X was in Nish's range, then that would make tons of upper value outliers. And so if he's saying there's only 5 outliers, the 5 that he's got at the bottom end, well, there's going to be a ton at the top. So therefore, that's a contradiction, and there would be values on the top end as well. Next, Luke wants to investigate using the ever great Beaufort conversion for Leeming in 2015. So still in Leeming, it's this very wind that we can feel a little bit right now, the very wind that Mr. Winfield measured about 20 of our real life minutes ago. He plans to select data until he has 25 pieces from each of the 3 categories. Now, excellent, well chosen question, Mr. Drew. This is quota sampling, something that we haven't seen in before in this series. He's sampling until he gets a specific number of each thing that he wants. However, the problem that Luke's going to run into is he's trying to sample until he has 25 light, 25 moderate and 25 fresh. Now, if you look at the large data set as closely and as much as I have in the last few days, you'll see that there are an absolute ton of light values, a few moderates, and by the time you get to fresh, there's barely any. So he's not going to be able to sample until he gets 25 fresh values because they're just not going to exist. So he's not going to get 25 fresh values. And that is all 9 marks of this large dataset question complete.
So it's taken us a long time to find it, but there is an air sock.
Oh yeah.
That's the same direction I said.
It's convenient.
Good work. Where is the weather station though?
I think it's here. I think it's one of the ones down there. I haven't got a mark, by the way.
We will be responsible, and we will take all of our litter home, of course, but we may leave one geocache. Let's go. Come and find it.
So as we headed out of Leeming, we saw a police car heading off in the opposite direction. Obviously that had been called out for the 2 layabouts recording outside of an RAF base, but that made no difference. We were on our way out, and we weren't focused on it at all because we, of course, were heading to our very last destination, which was pretty exciting because we were heading to Welcome to Scotland. Good times.